So you have made it already in your notebook. So this is the reactivity series, or we can say the activity series of the metal. And these are the some metals which are present, that is potassium, sodium, according to the reactivity. Okay, which type of reactivity? This I will tell you now. This series, whole series, this potassium ongoing from top to bottom, top to bottom, reactivity decreases. Decreasing chemical reactivity. Just write it, then I will tell you. Reactivity means platinum is very less reactive while potassium is most reactive. Okay,
Yes. Yes, ma'am.
that is this platinum is less reactive, or we can say least reactive, and this potassium is most reactive. Okay, all these metals from potassium till tin means all these elements which are above hydrogen in this reactivity series are more reactive than hydrogen. Okay,
Right. Uh,
means these metals are more reactive than hydrogen. And all the metals below hydrogen, that is copper, mercury, silver, gold, platinum. All the metals below hydrogen, that is copper to mercury to silver to gold and platinum, these are very less reactive than hydrogen. Okay, means all these elements which are above hydrogen, they will react in any of the chemical reactions. Okay, but these will not react because their octet are full. They don't need any electrons from outside, or they will not give their electrons to somebody else because they are already full. They have an noble gas configuration in the last shell, means they are maximum 2 or 8 electrons in the last shell, so they will not react with anybody. So who will react? All the atoms which are above hydrogen, means potassium, sodium, barium, all these things, they will react, but these will not react. So this is the table which is known as the reactivity series of the metals. This table, nothing, it's an arrangement of metal depending on the reactivity. Okay, from top to bottom reactivity decreases, means this is the least reactive and this is potassium is the most reactive. Understood? So
yes.
write it below hydrogen metals. These metals are very less reactive, are very less reactive than hydrogen. Written?
Yes.
Okay. Now we will apply some application related to this table. Okay. Now write the heading: reaction of metals with solutions of other metal. What does this line means? This lines means a more reactive metal a more reactive metal displaces a less reactive metal from its salt solution. Write it, then I'll give you example. It means that a more reactive metal displaces a less reactive metal from its salt solution. For example, have you seen an iron nail?
Yeah.
Yeah. When you put iron nail, when you put iron nail in a copper sulfate solution is a blue color solution. Okay. When you put this iron nail, okay, and you putting this in a copper sulfate solution, then after some time, then after some time, the blue color of copper sulfate, this blue color of copper sulfate will vanish, and there is only a reddish brown copper metal is formed. What does it mean? Copper metal is formed. This means this copper is displaced by this iron nail. Means it was having previous reddish brown color, okay, and it was put in a blue color solution. Logically, blue color solution must resist and in the solution, but this copper is less reactive than iron, so that's why this iron nail displaces copper, and there is only left with reddish brown color in the solution.
It become FeSO4.
Yeah, copper sulfate, CuSO4. Understood? And there is a formation of ferrous sulfate. Means if I will write the chemical reaction of this, then you are having copper sulfate solution. Okay, aqueous copper sulfate solution means water is there in it, and you are putting iron nails, which are solid. Obviously, this is solid and this is reddish in color. And after the reaction, this copper is displaced by this iron, and we will get ferrous sulfate solution, and copper will be out from the solution. How does it possible? Tell me. Tell. This is only possible. What did I told you about this reactivity series? Look, Umair, we are taking
More
taking
reactive
this.
metal with
Yeah, very good. We are taking iron, and we are taking copper. Okay, I'm using another pen. Let me take this. We are taking copper and we are taking iron. Okay, and we are putting this iron in copper. I told you just now that, Umair, whenever metal which are present hydrogen above the hydrogen, they all will react very fast, and these metal which are below hydrogen, they will react very less. This means when iron is put into copper, then this copper is displaced and iron come into its place, because this is more reactive. It react very fast than copper. Got it?
yes.
That's why this nail, this blue color got vanished, because this is less reactive. Copper is coming below hydrogen, na? Copper is coming below hydrogen. Okay,
Yes.
you see, and iron is coming above hydrogen, means this is more reactive. Okay, and this is
Yeah.
less reactive because reactivity decreases down the group. So this is less reactive, means copper is less reactive, so it is displaced, means it is out of the solution because of this nail, that is iron. Okay, and iron come above the series. So this is the application of this reactivity series. Okay, got it? So
Yes.
in your exam, any other metal would be given. which are above hydrogen, and some of the metal below hydrogen will be given. Then you will check on the reactivity series whether that particular metal is coming above hydrogen or below hydrogen. If it is coming above hydrogen, this means this will react, means the salt formation will be due to the metals which are above hydrogen. You are seeing salt formation, FeSO4. Who is making? Iron is making, means which are above hydrogen. This is iron. Got it?
Yeah.
Got it or not? I can
Yes, ma'am.
explain you one more time if you didn't get it.
I understand.
Okay, write it. So I'm writing that when an iron nail, first of all, write this line, then write the chemical reaction. Okay, when an iron nail, okay,
In the
is
example,
placed, yeah, yeah, in the example means reaction of metal with solution of other metals. Okay, solutions of other metal mean this is a solution, this is a solution, means two of the compounds are reacting, this is whole a solution, means copper is a metal and copper sulfate is whole as a solution, means reaction of metal what iron is, okay, with other solution of other metals, means this is solution, means iron is reacting with copper sulfate. As iron is more reactive, it will replace copper, okay, and will come in place of copper. Understood?
yes.
Okay, when an iron nail is placed in a copper sulfate solution in a right first in a copper sulfate solution, the blue color, the blue color of copper sulfate fades away slowly, and a reddish brown copper metal is formed. After writing this, write this chemical reaction.
Okay.
Okay. Now coming ahead toward next topic. Till now, what we have done the basic difference between metals and non-metals, their physical properties of metals, also non-metals, some exceptions. Then I talked to you about this reactivity series and its application. After that, now we are coming about what chemical properties of metals. Like physical properties of metals, we have done. Now chemical properties of metal. Chemically, how metals react. Okay, chemical, it's a new topic. Chemical properties of metals. In this topic, we will get to know how the metals, okay, how these metals will react with different solution, means how they will react with air, how they will react with water, how they will react with steam, how they will react with cold water, hot water, vapors, many chemical reaction we will with acid, with bases, how metal react with all these things. Okay, understood?
Yes.
Okay, at the heading chemical properties of metal.
Yes. Yes, ma'am.
Now first one is alkali metals. Alkali metals like lithium, sodium, potassium, etc., they all react vigorously with water. Okay. Okay. So you have,
Wait.
so what does it mean? Means it means a reaction of metals. What? Reaction of metals with air or oxygen. Okay. Got
What
it?
is alkali metal?
Alkali metals means, have you seen the periodic table? It's like this, I think. No? Okay, rows are there. Okay. So in this, the first row is a alkali metal row, and the second row is a alkaline earth metal row. Okay. In this first row, these metals usually come sodium, potassium, okay, lithium,
Okay.
sodium, potassium, beryllium, boron. These types of metals came in the alkali metal. That is first row of the periodic table. Second row is alkaline earth metal.
Mhm.
Okay. So if you want more detail about this, you can take out your books, and there is a periodic table which is being in your first page of the science book, or you can just Google it. You will get a periodic table. There you will get lithium, sodium, potassium in the first row, then other metals in the second row. These second row metals are known as alkaline earth metal, and the first row metals, they are known as alkali metals. Okay, got it?
Yeah.
Okay. So reaction of metal with air, or we can say oxygen. Oxygen is present in air. So what does this means? Means you're having metal. I am donating any metal. Okay, I am donating any metal from M. Okay, and we are reacting with water. Okay, metal is a solid, water is a liquid, obviously. Then what we will get? We will get metal hydroxide. Okay, or metal oxide, and there is always a release of H2 gas. Okay. For example, I am taking any metal like sodium. I am taking, okay, sodium, and I am reacting with water. Okay, what we will get? We will get metal hydroxide. MOH is metal hydroxide, and MO is metal oxide. Okay, then after reacting with this, we will get metal oxide, means Na2O. This sodium will combine with oxygen and H2 will release. Okay, and then again this metal oxide reacts with water because water is already present in the reaction, and finally we will get sodium hydroxide. What is what? A sodium. Done.
Yes.
Okay. So about chemical reaction of metals, first reaction will be the reaction of metals with air and oxygen. So this is the general equation of any metal. M can be any metal. Here I have taken sodium. Okay, any metal you can take: sodium, potassium, magnesium, aluminum, zinc, anything. है ना? And when we are reacting with water, there is the formation of either metal oxide or metal hydroxide. Metal oxide or metal hydroxide, and always H2 gas is released. Okay. You can say that, ma'am, why only metals react? Obviously, I told you that metals are having a deficiency of 1, 2, or 3 electrons. Okay. So either they usually what they usually used to donate their electrons. Okay. They will donate electrons. About how they will donate electrons? By these chemical reactions. Understood? When these
Yeah.
chemical reactions occur, then only they will gain electron or they will lose electron. Okay, then only these things come into play when two things will react. Okay, understood? So
Yes.
This is the reason metal used to react, because they are having a insufficient electron in the outermost shell, and to attain the stability or the noble gas configuration, they used to react and complete their octet. Okay, so when they, so different metals will show different property with different things. Okay, so when metal, so first property is when they will react with water. Okay, when metal react with water, there is the formation of metal oxide or metal hydroxide. Okay, NH2 gas. So we have taken the example of sodium. When sodium reacts with water, what will we do? Sodium and oxygen will combine with each other and H2 gas will release. When they will combine, they will form this Na2O. This reaction doesn't stop here, because in this there is an exception, because sodium and potassium are the two metals which are very reactive. They are this much reactive when they combine with water or they use kept in the atmosphere, they usually catch fire. Why they used to catch fire? Because there is a release of H2 gas. Just because of this H2 gas release, this sodium oxide when formed, they again react with water molecule and sodium hydroxide is formed. Understood? So in
Yeah.
your notebook, there is a question, sorry, in your textbook, there is a question, why sodium and potassium react vigorously, and what is the chemical reaction of this? Okay, so in physical properties also we have done various what we call, along with the properties we have done various mm, exceptions also, and some unique properties. So in reaction of metals also, sodium and potassium are the two metal which reacts vigorously and they catches fire immediately. They catches fire, and what, they will disappear after catching fire, they will destroy. So to prevent this fire, we usually kept it due to kerosene oil.
Yeah.
Now get it? Why did I told you that example yesterday? That day.
Yes,
Okay,
ma'am.
I made you write a question. Why sodium or potassium usually used to kept immersed in a kerosene oil?
Yeah.
Okay. So you can say, ma'am, why, if they are reacting and if they are catching fire, then why we are making to do this? This is not our problem. We are just writing the behavior they show when they react with water. Okay, we are just writing the properties. Okay, we are not discussing about the hazardness or the impact of this chemical reaction, this particular chemical reaction. We are just writing, or we are just dealing with the properties of this metal. So this is the property of this sodium and potassium and how they react with water and why they are vigorous, why they are kept in kerosene oil. All these things you have to remember in your tips. Got it? Okay.
Yeah.
So I know this is so messy. I'll make you write each and everything. First of all, you have write this reaction of metals with air and water. Okay. Then after that, write this reaction of metal, alkali metal like sodium, potassium, etc. react vigorously with water. Why vigorously? Because they catch fire. So okay. So and after that, write the general reaction, that is metal when react with water, they form this. Okay. Then put examples and write this. Okay. I'm cleaning and I'm writing again. We are having sodium. Okay. We are having water and they are reacting. We get sodium oxide and water. Just due to this readily reactive nature, this sodium oxide again reacts with water and is the formation of sodium hydroxide. 2 moles of sodium hydroxide. Okay, like this.
Okay. Okay.
Done.
Yeah.
Okay. So overall, this is formed. Again, example similarly. Second example is when potassium reacts with water. When metal reacts with water, there is the formation of metal hydroxide, means potassium hydroxide. Metal hydroxide. Okay. When potassium reacts with water, they again form metal hydroxide, that is KOH. Okay.
Yeah.
Write it. Okay,
Okay, ma'am. Done.
this hydrogen release. Okay, hydrogen is a gas. Hello.
Hello, ma'am.
Yes.
Yeah, can you hear me?
Yes. Yes. So right, this hydrogen gas, this gas burned. Just because of this gas, sodium catches fires. Okay. This gas burned because I'm writing because in a short form CUS. Okay. CUZ. This reaction burned because the reaction is so exothermic. Means there is exothermic means there is a lot of amount of heat is liberated. Okay. Exothermic that the heat liberate
The heat liberate
that the heat liberated out during the reaction.
during the reaction.
Okay. Let the hydrogen gas let the hydrogen gas produced
Reduce.
to catch fire. Okay.
Catch fire. Okay. Yeah.
Yeah. So basically we have taken till now two metals, sodium and potassium. When sodium reacts with water, there is a formation of sodium hydroxide. When potassium reacts with water, there is a formation of potassium hydroxide. Now, what will happen when metal react with cold water? There is a variety in meaning of the water: simple water, cold water, hot water,
Ma'am, then
steam.
in K plus H2O, one H atom will be extra.
Okay, this is the chemical reaction. Sorry, balancing of the reaction. You have done balancing of the reaction in lower classes. Hmm? Tell.
No, one H atom is extra. Less.
Yeah, yeah. One H is less. We can make it like this. Okay. It means that we are having two hydrogen and two potassium, so two will also come here. This is a balancing of the reaction. Okay.
Then
For
it is
this,
two.
for this, there is a particular chapter you are having.
Then there is two O, ma'am, but only one O. Then here four
Yeah,
hydrogens.
yeah, yeah,
Here
yeah.
only.
Wait, we are taking 2 moles of potassium and we are taking 2 moles of water. It means there is a formation of 2 moles of KOH. Okay, and
Plus
H2
H2.
gas will release because there are four H2 means
Yeah.
2H will come here and 2H will come here. Two potassium is here, two potassium is here. Okay, two oxygen is here
Yes.
and two oxygen is here. This is a balancing of the reaction. In general, we can write like this also. Okay, you can write like this also. Okay, heat energies are also released. Just because of this heat energy, or we can say the exothermic reaction property of this potassium hydroxide, they catches fire.
Yes, ma'am.
Yes, write it. Okay,
Yeah.
or we can write this was the reaction of metal with water. Now if we react metal with oxygen, this wait, right here water. Okay, because water is, if the metal reacts with oxygen, okay, then when metal reacts with oxygen, there is a formation of metal oxide. Okay, metal oxide. For example, I'm taking potassium. When potassium reacts with oxygen, they form a potassium oxide. Metal oxide means potassium oxide. If we balance out this reaction, we can do like this. We can take 4 moles of potassium. So if it is 4 moles of potassium and 2 moles of oxygen, then there must be a 2 outside this and 2 potassium this. Now it is balanced, I think. Okay.
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 4K plus O2.
Yeah, 4K.
Okay.
Now, um, cold water reactions. Okay. So in cold water, only one metal reacts. That is C for cold, C for calcium. Okay, right like this. Please remember the name of the metal and their conditions. Means cold water, somebody asks you which metal reacts with cold water, calcium. Which metal reacts with hot water, magnesium. Okay. Which metal reacts with steam? We can say aluminium iron. Okay. Okay. So try to remember
But
the name of the
potassium and sodium react with
potassium
everything.
and sodium reacts with water, normal water.
With
Okay.
everything,
Yeah, it can do also with everything, but in your books it is given that sodium potassium will react with normal water. They don't mention whether it is hot, cold, or steam. But particularly some of the metal, they will only react with cold water in any condition. Okay, that is calcium. Magnesium, hot water. Okay, so calcium, when it reacts with cold water, there is a specific reaction steps. In first step, when calcium reacts with water, they form what? I told you just now, metal when reacts with water, they form metal oxide. When metal reacts with water, they form metal hydroxide or metal oxide. Okay. When sodium reacts with water, they form sodium oxide. Okay. When calcium reacts with water, they form calcium oxide. Also, there is always a release of H2.
hydrogen gas.
Okay. But second
Yeah.
step of this reaction is step 2. This calcium oxide again react with water. Okay. This cold water. Okay. They will itself do this. Okay. And the formation of calcium hydroxide and H2 gas will release. So overall reaction, what is this? Overall reaction is nothing, just calcium plus water forms calcium hydroxide and H2 release. Okay. Okay. If somebody asks you, just write this overall reaction. If they will ask step by step, then told this. First of all, calcium oxide will be formed. Calcium oxide will be formed. After that, calcium oxide again react with water, and we will got calcium hydroxide. Okay. Sorry, calcium hydroxide. Wait. Water is present now, so hydroxide means H, hydrogen. Hydroxide. Then which metal will react with hot water?
Magnesium.
Magnesium. Okay.
Yeah.
We can remember it like this: hot water means somewhat magnesium is also having parallel lines, hot water is also having parallel line. So we can somewhat like this. Hope you got it.
Mm, mm, very
Just a short mnemonic. It's up to you. You can make how you want to.
okay.
So magnesium overall reaction of magnesium is when magnesium reacts with water, hot water. Okay, they will form again. What this is calcium hydroxide, now magnesium hydroxide. Magnesium and obviously H2 gas will release.
Okay. Okay, ma'am.
Okay. Okay. Where from uh, in in the next lecture I will be hearing this series from you. Okay. You have to learn it by heart. First of all, potassium, sodium, barium, calcium, magnesium, aluminum, zinc, iron. Because due to this, you will solve many problems of like this. I'm giving you an example of copper sulfate. Might be some other teacher gave you some other metal, some other um, oxides, or we can say some other solutions. Okay, then you how you will do if you will not remember this table. Got it? Got it?
Yes, ma'am.
Mm. So try to learn this. Okay.
Okay.
So we have done. Um, we have taken sodium and potassium. So chemical properties we were doing of metals. Quickly, I'm revising chemical properties of metals we have done. So first of all, we have taken sodium metal and potassium metal. Okay, when metal reacts with water, they form metal hydroxide or metal oxide. Okay,
Yeah.
so when sodium reacts, they form sodium oxide and H2 gas because this reaction is so exothermic that it again reacts with water and there is formation of sodium hydroxide. Okay. Similarly with potassium. So due to this reason, they are kept in kerosene oil. Okay.
Yeah.
Okay.
Even potassium is kept in kerosene oil.
Ah yes, sodium and potassium both.
Okay.
And this after that when they will react with oxygen they will form metal oxide. Okay, metal when react with oxygen they form that like we are taking potassium when reacts with oxygen they form potassium oxide.
Okay.
Okay, and second category is cold water, reaction of metal with cold water. Only one metal reacts with cold water, that is calcium, and they form formation of first of all calcium oxide, and calcium oxide again reacts with water. They formation of calcium hydroxide. Overall reaction you have to learn this. Okay, if it is a long answer question, means 4 or 5 marks question, then you can write all these things. If it's in the 1 marks question or 2 marks question, then write just this. Okay, and try to
Okay.
highlight each and everything. This is calcium hydroxide, this is hydrogen gas release. Then there will be a more impact on your answer. Okay, then teacher will get to know that you know very deeply. Okay,
Okay.
this is Ca is a calcium. Just write it because you are in your very starting classes, that is 10th. Okay, in higher classes when you will do like this, then it is okay. Okay, teacher is understood that you know everything. Okay,
Yeah.
but in 10th you have to like. Now the next metal is magnesium. When magnesium reacts with water, we got a magnesium hydroxide. Next metal what is left is this aluminium, iron, and zinc.
Okay.
Okay, these all metal neither react with cold water, neither react with hot water. Sorry, hot water. Okay, so what is left? They all will react with steam. Okay. Okay, so what is the chemical reaction of this particular metal? First of all, we are taking aluminium. Okay, we are taking aluminium. Aluminium when reacts with water. Okay, in a gaseous form. Obviously, gaseous form is there. This means vapor is there. Vapor is there means steam is there. Okay, so try to write this because aluminium has this property of reacting with steam. Okay, so mention it. How will another person in front of you will got to know that which type of water you have taken? Okay,
Yeah.
in calcium also in bracket like write cold condition. Okay, in magnesium also write in hot conditions. So aluminium when reacts with gaseous water, then we will get aluminium oxide, and H2 gas will release. Similarly, I am taking iron. Okay, when iron reacts with water, that is steam condition, then we will got same aluminium oxide is it is there, and in this we will got iron oxide, and H2 gas will release. Okay, and next what is left is zinc. When zinc reacts with water, then we will get zinc oxide, and H2 gas will release. Okay, and in this there is a condition, always iron is a red hot iron is taken, not a solid one in the normal temperature. No, it is firstly burned, and it is burned this much till when it is red hot. Okay, red hot iron is used. Okay, so what did we have written? We have written that aluminium, iron, and zinc are metals, are metals that does not react with, that does not react with either hot, cold water, but but with steam. They will react and and release of what? Metal oxide and hydrogen.
Okay, ma'am.
Then
Okay, ma'am. Yeah.
finally, other metals um, rest metals, like what is it, like below hydrogen, that is copper, silver, platinum, gold. All these does not react with water or dilute acid. Okay, the reason you already know. Okay, the reason is because they are present what below water in the reactivity series. Okay, neither they react with they
No.
yes,
No, ma'am.
they also don't react with, you can say, ma'am, if they are not reacting with water or dilute acid, might be they react with cold water or hot or steam. No, they don't either react with cold water, hot water or steam. Okay, because they are not stronger, not strong enough reducing agent to displace H2 and H2. Write it. From next class, we will continue with the next topic. Okay, that is reaction of metal with oxygen reaction. Okay,
We did with oxygen.
mm. And
Ma'am,
amphoteric oxide. Meaning of
we
amphoteric
finished
oxide.
with
Yeah,
oxygen,
yeah,
right?
yeah, 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 yeah. Okay.
Ma'am, what is there are two ferrous oxide, right?
Ferrous oxide what?
There are two ferrous oxide, right? Fe2O3 and Fe3O4.
Fe3. Yeah, yeah.
What to use at what time? Or if we use anything also correct only.
Yeah, 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 yeah. That I will tell you tomorrow. It depends on the charge. If iron is having +2 charge, or if iron is having +3 charge, if it is having +3 charge as a whole, then we will use ferric. And if it is having +2 charge, then we will get to know. We will know. We will say it ferrous. Okay. This I will tell you.
How to know if it is at 2 or 3?
Yeah, 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 yeah. This we will calculate like this. We're having Fe3O4. Suppose this is X, then 3X plus oxygen is having negative mass. It's a detailed chapter.
Okay.
Okay, like this. Tomorrow I will tell you, okay? Because
Okay.
many people are joining.
Okay. Sure.
Okay, okay.
Hello, Shira. Good evening.
Hello, sir. Good evening.
So, have you solved the question of dissolution?
I read yesterday's question, what we did in class.
What we did in the class, that's it.
Yeah, sir, I was doing project, so I practiced this.
But you have the examination also.
Yeah.
So you need to solve some question for that.
Yeah.
So if you focus only on projects, then how can you like practice some question, revise the concept?
Yeah, so